Hello everyone. So today I will be talking about the how we can test the convexity of a function of two variables. So last class we have seen of one variable. So today I will be seeing of two variable. Okay. Okay. So let's suppose take an example and then we will proceed further. So take an example if just write a function of two variables. Okay. So f take x1 and x2 are the two variables. X1 square plus 2x1 x2 plus x2 square. This is one function which is having two variables. So how we can understand that this is a convex function or concave function? So for this purpose we determine some of the terms, okay, and then so there is a something known as Hessian matrix. Okay, so Hessian matrix is defined as del 2 f, that is f, okay, and upon del x1 square, then del 2f upon del x1 and del x2. Here del 2f upon del x1 del x2 and del 2f upon del x2 square. Okay, so this is a Hessian matrix. So we need this Hessian matrix to determine the convexity test. So let's start calculating all the terms. Okay, so first term is del 2f upon del x1 square. Okay, so this we will calculate here, del 2f upon del x1 square. So first we need to find del f upon del x1, that is partial derivative of that function with respect to x1. So calculate it, del f upon del x1. How much it will come? So partial derivative of this function with respect to x1. So here x1 we have, so it will be 2x1 plus this is also having x1, so it will be remaining 2x2. This is not having any x1 term, so this will be 0. Similarly, we need del f upon del x2. So how much it will be? 2x1, because here x2 term, here there is no x2 term, so this will be 0, and this one will be 2x1 plus here x2 term is there, so it will be 2x2. Sorry. Okay, now we will calculate del 2f upon del x1 square is equal to, now again you have to differentiate this one with respect to x1. So here we have x1 term, so this will be 2 plus this is not having any x1 term, so it will be 0. Now here del 2f upon del x2 is equal to, check it here, is there any here x2 term is not there, so it will be 0 plus this is 2. Now so these terms are we have determined, and what else is left? This one is left. So find out, because this and this both are same, so del 2f upon del x1 del x2 means del f upon del x1 is again differentiated partially by with respect to x2. So this is denoted by this one. So this will be differentiated with respect to x2. See, here we have differentiated with respect to x1. Here in this term we will be differentiating this one with respect to x2. So how much it will be? Again it will be this will be 0 because there is no x2 term here, and this will be 2. You will see that here if you differentiate this function also with respect to x, this will be actually del x2 del x1. Okay, here it is del x2 del x1. This is actually same, so both will be same. Okay, so now we have got all the terms of Hessian matrix. Okay, so now we will check what are the conditions which are required, okay, to determine that it is a convex function or concave function. So there are three terms which we need to check. Okay, first term is del 2f del x1 square into del 2f upon del x2 square minus del 2f upon del x1 del x2 whole square. This should be always greater than 0. It should never be negative. Okay, it should never be negative, then only it will be, you can test convex and concave. Second term is del 2f upon del x1 square. If it is greater than equal to 0, then it will be convex. It will be convex. And if it is less than 0 or equal to 0, then it will be concave. The function will be convex and concave. See, here, this actually for getting it convex, you need to have both greater than or equal to 0. Then only you can tell it is convex, and in this case it should be less than equal to 0. So both should be less than equal to 0, then only it will be known as concave. So here you check this value. This is here it is 2. If you check for this function, just 1 minute, okay, this is very important, you have to remember. Sorry. So this one you have to remember, that's all. If these three terms are all greater than equal to 0, then it will be known as convex function. If this is greater than 0, the first term, and the rest two terms are less than 0, then it will be known as concave function. So check here, this function is a convex or concave. So put the values delta 2f upon del x1 square is equal to 2. So this is 2 into 2, 4, minus this is also 4. So 4 minus 4 is equal to 0. So here it is written greater than or equal to 0, means it is satisfying the condition. It is actually, so just determine the first term. Oh, sorry. So the first term is actually 2 into 2 minus 2 square, that is 0. So obviously this is satisfying. Second one obviously 2 which is greater than 0, and third one also 2 greater than 0. So obviously the function is a convex function. Clear? So given function is convex function. So now you can similarly you can check any function which is having two variables, whether it is a convex function or concave function. If the function is a convex function, that means how the curve will be, it will be a strictly it will be decreasing curve. Are you getting? Sorry, it will be increasing function curve like this. Sorry, it will be like this. Convex means, okay, this will be convex downward. Okay, this side will be downward, so you will get minimum value. Clear? But if it is a concave function, then already in the uh, last class we have seen, then you will be getting maximum value. Okay, so it's a continuously it is a concave and convex. So in this way you find out the value. Let's take another example and you try it for yourself and see that that function is a convex or concave function. So can take the note, this is a concave function, sorry, convex function, and this one is concave function. Take one example here. F x1 x2 3x1 square minus 5x1 x2 plus 4x2 square. This is a function. Check that whether this function is a convex function or concave function. In next class we will go for convexity test of a function of more than two variables. How to find out the convexity test, whether it is a concave or convex, we will see in the next class. So thank you very much.